find the domain of rational functions is, let's put this in another color. We take the denominator and set it equal to 0. And I really am going to say not equal to 0. We try to find the values that are not equal to 0 because we don't want this to be 0. We want to find those values that are the exclusions. So I'm going to do x squared plus 4x plus 4. And then I'm going to say, okay, I'm going to go ahead and say equals 0 because what values will make that 0, but I want to exclude those. Again, it's a quadratic, so we're solving this quadratic. So I'm going to factor this. I'm going to do an x and an x, and this one's going to factor with a 2 and a 2. All right, so that meant that this was a perfect square trinomial in that factoring. All right, but I didn't factor it like that. I didn't factor it using the formula. I factored it just like normal. But the fact that I got 2 of the same terms tells me it was a perfect square trinomial. All right, so both of these, all right, means that x cannot be -2. All right, I'm wanting to know if I plug -2 in here, it's going to make it equal to 0. I don't want that. I can't have that. So then that means that this is an exclusion from the domain. All right, so again, if you need to picture this on your number line, here's -2. I cannot have that number in my domain, but all of these numbers I can, all the way out to -infinity, and all of these numbers I can, all the way out to positive infinity. So then we've done this number line approach before for our interval notation. So our domain using interval notation would be -infinity to -2, skip over -2, -2 to infinity. All right, so we have done that multiple times, but it's been a while. I haven't done one of those problems in actually quite a long time. All right, now for the second type of function that we have done algebraically, f of x is equal to, say, the square root of 2x minus 1. Okay, so here again, we work in the real number system for the most part, which means that we do not want to take the square root of a negative number. Because as soon as we take the square root of a negative number, then that gives me an I, or an imaginary number. So to avoid that, then I want to say, okay, this needs to be greater than or equal to 0. I can take the square root of 0 and get 0. All right, I do not want it to be -1, -0.5, negative anything else. So that right there is my rule for what I need to memorize. So I'm going to do 2x minus 1 greater than or equal to 0. Go ahead and solve that. 2x greater than or equal to 1, divide by 2. X is greater than or equal to 1/2. All right, now again, I want interval notation for this domain. So picture your number line. All right, here would be 1/2. All right, with the equal to part, that means 1/2 is included in my domain. So solid dot. All right, or as we have learned with our interval notation, square bracket. Okay, same thing. You use that solid dot in high school, square bracket in your interval notation now in your college algebra. All right, x is greater than 1/2. Well, the numbers that would be bigger than 1/2 are over here, within positive infinity being all the way down here. So again, I can look at that number line and then come up with my domain, which is going to be nothing more than a square bracket 1/2 to infinity. All right, so obviously,